Okay, what we have here is a kinematics problem. So we've got a particle that's traveling there. We have all that. Find the particle's displacement after 2 seconds. So what we are going to have to do to solve this problem is we are going to have to find the integral from 0 to 2 of 1 minus t times the sine of 2t dt. Now, that does not integrate very well as such because I don't have common things. So I'm going to expand that. So I'm going to end up with the sine of 2t minus t sines of 2t dt. Now, that I can split because it's just subtraction. So that's actually the sine of 2t dt minus the integral of t sine 2t dt. Let's tackle this first one first. So that would be the sine. I've got to use a u substitution because it doesn't equally work out very well. And in this case, my u is 2t's. So du dt would give me 2, meaning that dt is the same as du over 2. Plugging that back in, I get the sine of u du over 2. Well, the integral of sine u is negative cosine u times 1/2, like I guess I should put parentheses there, times 1/2 and then plus c. So getting that all together, I get negative 1/2 cosine u plus c. And my u is 2t, so this becomes negative 1/2 cosine u plus c. So that is my first one here. So I've got that integral. Now, this other integral that they've given us, I can see already that's a parts problem. And we love parts problem. So to do that one, we have to figure out integration by parts. We have u equals I late. So in this case, my u is t, and my derivative of u would be 1. That means that my v, that's the derivative is going to be the sine of 2t, which it just so happens we know from right there. So that is negative 1/2 cosine 2t. Setting up integration by parts, it's always uv minus the integral of vu. So that's going to be t times negative 1/2 cosine 2t minus the integral, sorry, I screwed that up, the integral of negative 1/2 cosine 2t times 1. And we're going to do that with respect to t. So this front part becomes negative t over 2 cosine of 2t. To do this integral, we've got to do that same u sub. So negative 1/2 cosine of u dt. My u is, well, it's the exact same u as here. It's that exact same thing. So this would turn into negative 1/2 cosine of u du over 2. So it would, that's going to turn into negative 1/4. Sorry, we're taking that integral of sine u, and u is 2t's plus c. So if I bring that over, I would have minus 1/4 sine 2t, and all of this is plus c at the end. So all together, if I bring all of my parts together, I would have negative 1/2 cosine of 2t, and then here I just gotta make sure I am subtracting, so this all gets subtracted. So I get plus t over 2 cosine 2t's. So that is a minus, so that's a plus on the inside, so it's a minus now, 1/4 sine 2t plus c. So my overall antiderivative is that. Now if I wanted to, because I don't know, I'm a glutton for punishment, I guess I could combine these two. So because those are both the same, I could do t minus 1 over 2 cosine 2t's minus 1/4 sine of 2t's plus c, and that would give me that antiderivative, which I could then use to answer the question, which is the displacement after 2 seconds. So that displacement after 2 seconds, I would have to evaluate that from 0 to 2, and so that'd be 2 minus 1 over 2 cosine of 4 minus 1 over 4 sine of 4, and all of that minus negative 1/2 cosine of 0. That sine is going to go away as well, and cosine of 0 is 1, and we can evaluate and solve. I really hope that is helpful. I know I didn't finish the whole problem, but that at least explains where these values are coming from. Have a good